Hi there, I'm Hao, and this is just another video of me solving random numerical problem. So given the head of a linked list, return the list after sorting it in ascending order. So we can do it in several ways. We can use bubble sort, right, insertion sort, or selection sort, right? But this will give us a O of n runtime, but the space will be optimized. But I think we want to optimize for the runtime here, so we can use quick sort or merge sort. Quick sort give us amount, the average case would be the average case for time complexity would be O of n log n. But if we encounter an array that is almost sorted or already sorted, then it would be O of n squared, right? Because we need to split the array n time, right? If it is if the pivot is randomized, then we can split the array in half every time for each recursion call, right? But if the array is sorted, then we always have the array of n side on one side and an empty array on the other side, right? So uh, that is not good. But if we use merge sort, then we know that the worst case for the time complexity will always be n log n, right? It takes log n time to split the input in half, right? And then we take n time to merge the two half together. So together we're gonna have the time complexity of n log n. Okay. So let's try to implement this. Assuming we are already familiar with the merge sort. So if we have the array like this, right, we can split it in half, so 4 and 2, right? 4 and 2, 1 and 3. Right, and we just keep doing it. Right, 4 to no, this 2 to no, right? It is like 1 to no, and then 3 to no, right? And then we can merge them together, right? So first of all, um, how do we find the middle node of the linked list? Right? If we have a fast and a slow uh, pointer here, where the fast pointer is one step ahead of the slow pointer, right? And we're gonna move the slow pointer by 1, with the fast pointer by 2, right? If the fast pointer is null or the fast pointer dot next is null, then we stop. Then we break the while loop. When we break the while loop, we know that the slow pointer will point at the first middle element, right? Let's say we have another node right here, right? And we have to increment one more time. Right? Fast is next, right? Fast will be here, which is null, right? So we break the while loop, and the slow pointer we're always pointing at the first middle element. If we have two middle elements in the slow pointer, we always point at the first middle element. Okay, so using that way, we can find the middle element, which is the slow here, right? We can set the slow dot next to null, right? To split the array in half, like this, right? And we just keep call the merge sort method recursively until we have one element or no, right? So if the head is no or the head of next is no, we want to return the head, right? So this will be our base case. But if the linked list only have one or zero element, then there's no point of putting it, right? We can just return back up, right? So that is our base case. We cover how to find the middle node, the first middle node in on the linked list. So now we can split them in half. We have our base case. So now, how do we sort them together, right? So we can create a dummy node. So this is like a dummy node, dumb, okay? And then we can just keep iterating through the two lists, right? Until either list is empty. So if four, we compare 4 and 1, right? So 1 is smaller, so we porting this to 1, right? And we increment this pointer. Oh, sorry, we are merging on the on this side first. So we compare 2 and 4, right? So 2 is smaller than 4, so we set 2, and then we increment the right pointer, the pointer on the right side here. So because now the one of the lists, we are merging two lists, right? Because one of the lists is null, so we break out of the while loop and then just point it to whatever remaining. So if list one is not null, then we just point the next pointer to list one, right? And vice versa. Right. So let me reroll this. So this one is done. This is what we have right now, 2 to 4. So we do the same thing over here. We have a dummy node, right? And yeah, and after that we can return the node of next. Right? Same thing here. We have two pointer. One is smaller than 3, so we point to 1. Right, 3 is smaller. So now it's null. So we break out the while loop, and then we just connect it to 3 because 3 is not null. The right side, the second list is not null. 3. Okay, so this side is also done. Right. So we already merged the two sides. Now we need to merge these two lists, right? Let me make some space here. So we can have a dummy node, right? And we just compare the two elements, right? One is smaller, so we add 1. We move to the next pointer. 2 is smaller than 3, so 2. So 4 here. The 3 is smaller than 4, 3, right? And this one was to know, right? So we just point it to whatever remaining, right? Which is 4. Okay, and we can return the dummy node dot next. So that is the general algorithm. So the first thing we would do, is we would find the middle node, right? And specifically, we want to find the first middle node. And why do we want to find the first middle node, but not the second middle node? Because imagine if we only have two nodes like this, right? And we have a slow pointer and a fast pointer here. The slow increment by 1 and the fast increment by 2. There's just no here, right? If this is our middle node, then the array will be split like this, right? We give us we put it into an infinite loop because we want to split the two elements like this, right? Because we want to pass in the head and the head is 4, right? 4, and then uh the slow will be the tail, right? Of the first half. So first 2, right? And then the right side would be slow dot next, right? And always been null. So we just keep getting stuck in this infinite loop if we use the second middle node. Okay. So we need a merge sort typer here. Let's call it left head. Right, we have the left head and the right head. So we can call this left head merge sort, passing in the head, and we can return it. Okay. So we need a fast and a slow pointer. and this is not effect. So remember, the fast pointer has to be one step ahead of the slow pointer. Right. I mean, you get the first you don't know. Okay, we can just increment our pointer. The fast pointer will go twice as fast. Right. If the fast pointer goes twice as fast, then which means when the fast pointer reaches the end, we know that the slow pointer will be somewhere in the middle, right? So that makes sense. So after we break out of the while loop, we know that slow pointer is in the middle now. So we have to split the list into two, right? So we have to do slow.next equal to no. To split the list into two lists, right? And before we do that, we also need to take the right hat equal to slow.next. Right? So the star of the right hat of the right list will be slow.next, right? So whatever before slow, right? We want to cut it off, setting the slow.next equal to no. And after that, we can return the merge of merge search, the left hat, right, and the right hat, right? So we just keep calling the recursive method, right? So what is our base case? As mentioned earlier, if we don't have a head, if we only have zero or one element, and we want to return the left half, right? So the left half will either be null or the first element, okay? And then the only thing left to do now is to merge. So merge equal to we gonna have list one and list two. Right, we are merging two lists. As for this new head, which is our dummy node. So right, so new list node of that we will return the new head or next at the end. Right, and y list one and list two. Right, we need our current pointer. Uh, equal to new head. Right. So if the list one dot value is less than list two dot value, we want to set the current uh dot next, right, equal to this one, and then we want to increment this one, right, pointer. And we want to do the opposite for this two, and we want to update our current pointer. Okay, so after the while loop, it's mean that either one or two, this one or this two is no. So we just set the tail of our new head, right, which is the curve here, that next equal to either this one or this two. And we can return our new head. So let's try this. Accept it. And thank you for watching.